Hello Honors Pre-Calculus students, this is Mr. Gusato, and today's learning target is to solve rational inequalities without a graph. So if you recall, back in chapter 1, we solved problem number 1 by drawing a number line and putting the critical points on the number line. That's when the numerator is 0, so 7, or when the denominator is 0, -5. Since we want a strict less than, both of these points will be open circles. And then what we did is we tested each section. So suppose you were to pick a number 8, the numerator is positive, the denominator is positive, so to the right of 7, that fraction will be positive. Pick a number between -5 and 7, say 0. The numerator will be positive, remember you are squaring a number, over a positive, so in between here, positive. And to the left of -5, say -10, we're going to have a positive, because when you square a negative, you get a positive, over a negative, so to the left of -5, we will be negative. We want to know when the graph is strictly less than 0, so we want this green shaded section. So the answer would be -infinity up to -5, not including. The other thing that I want to point out is this x-intercept of 7, it would just touch the x-axis. So notice this is positive and this is positive, so you could use that to your advantage. And then if you look at the denominator, we have x plus 5. Around that vertical asymptote, 1 is up and 1 is down. That's why this is positive here in green and then negative. So you could use that to your advantage, the multiplicities. I would suggest you pause the video and try problem number 2. For problem number 2, let's put the critical points. So we have 6, we have -2, and we have -3. For this particular problem, we want greater than or equal. So that means can never be -3, so I'm going to put an open circle because that makes the denominator 0. But you can be -2 and you can be 6 because that's going to make the fraction 0. Again, I'm going to check each section. So if you plug a number bigger than 6, numerator will be positive, positive over a positive. To the right of 6, it's positive. If you pick a number between -2 and 6, say 0, this will be negative, positive over a positive. So that will be negative. Pick a number like -2.5. We have a negative over a positive. So that'll be positive. And to the left of -3, we'll have a negative over a positive. Remember, when you square a negative, you get a positive value. So this is positive. Now we could also use the idea of multiplicities. So once I know this is positive here at 6. X minus 6 has an exponent of 1, so that has to be a negative. The -2 has an exponent of 1, so they have to alternate signs. So there's the positive. And around the vertical asymptote, the exponent is 2, so they're going in the same direction. So since to the right of -3 was positive, this last value has to be positive. If you like that method, please utilize that to your advantage. So we want to know when this is greater than or equal to 0. So we want to the left of -3. We want in between -3 and -2. And then we want to the right of 6. So the answer here would be -infinity to -3, not including, union -3 to -2 with a bracket, union, bracket, 6 to infinity. For problems 3 and 4, if you take a look at them, they're very similar to number 1 and 2. The only difference is these are not in factored form. So it would be my suggestion that you factor problem 3 and 4, and then you solve the inequalities like we did problem number 1 and 2. So I'm going to pause the screen here. You're going to try factoring number 3 and solve it. Then you should factor number 4 and solve it. Okay, if you take a look at problem number 3, I factored it. I drew my number line, and I have the work there. And then we're looking for this to be strictly greater than 0. So on the number line, all of these points will be open circles. So you can't have 0 in the denominator, you can't have 0 in the numerator. We're looking for when this is greater than 0, so we want in between -7 and 4, and to the right of -3. So the answer would be -7 to -4, union -3 to infinity. Go ahead and try problem number 4. So for problem number 4, I did the factoring, and here I want strictly less than or equal to 0. So that means the numerator could be 0 and the denominator cannot be. So we're going to have open circles at -6, -3. We'll have closed dots, meaning we can include the -5 and 5. We're looking for less than 0. So we are in this shaded section. So the answer to this problem would be -6 to -5, union -3 to 5 with a bracket. For this particular problem, I did use the multiplicities. So once I figured out that to the right of 5 was positive, I used the idea that all these exponents are 1. So then the signs must alternate. So once I knew that positive, I then figured out that was negative, then a positive, negative, and a positive. Okay, problem number 5. We have a rational inequality again. The most common mistake would be to multiply and write the equation x plus 43 is less than 4 times the quantity 5x plus 25. So I'm going to write that down. I do not want you to write this down. This is the most common mistake. The reason you cannot do this is when you multiply by 5x plus 25, you do not know if that quantity is positive or negative, so you do not know what happens to that inequality. So do not multiply by 5x plus 25. So in order to solve this inequality, we need to make it similar to the previous questions. What I mean by that is we need to get one side equal to 0. So in order to solve this inequality, we're going to subtract 4 from both sides. Then we need to get a common denominator. So the common denominator is going to be 5x plus 25. So I'm going to write that down. So in essence, I am multiplying by the number 1. So last year you should have gotten common denominators. Then we're going to get x plus 43. Make sure you distribute properly. Minus 20x minus 100 over 5x plus 25. And then combining like terms, you're going to get negative 19x plus 57 minus 57 over 5x plus 25. At this point, we need to draw the number line and find our critical points. So if you look at the numerator, negative 19x minus 57, when will that be equal to 0? That's equal to 0 at negative 3. The denominator is equal to 0 at negative 5. Then if you test each section, if you pick a number to the right of negative 3, the numerator will be, so let's pick 0, negative over a positive, which will be negative. Pick a number like negative 4, this will be positive over a positive. And to the left of negative 5, say negative 20, we'll have a positive over a negative, which is negative. You again can use the multiplicities. For this problem, we want a strict less than, so we will have open circles at both points. We're looking for when it is less than 0, so we want to the right of negative 3 and to the left of negative 5. So the answer here would be negative infinity to negative 5 with a parenthesis, union negative 3 to infinity. For problem number 6, again, the most common mistake in number 8 would be to write the following. I'm going to write it down, but I'm going to put a big X through it. You are not allowed to multiply like I just did, what some people call cross multiplying, because you are not sure what happens to the inequality. You're not sure if you're multiplying by a positive or a negative. So do not do that. In order to solve this problem, we have to do the similar method as number 5, meaning we need to set it equal to 0. So I'm going to subtract 7 over x minus 1. And now we need to combine the rational functions. So the common denominator is x minus 2 times x minus 1. So I'm going to multiply to get the common denominator. Then make sure you distribute properly. So 8x minus 8 minus 7x plus 14 over that denominator. It's strictly greater than 0. Combining like terms, you get x plus 6 over x minus 2, x minus 1. And again, we're going to use the number line approach. So we have negative 6, we have positive 1, we have positive 2. Checking the intervals, if you pick a number to the right of 2, that quotient will be positive. So you have positive, positive, positive. Pick 1.5, you have a positive over a negative and a positive, so we're negative here. Pick the number 0, you have a positive over a negative, negative, so you're positive. Pick a number to the left of negative 6, you'll have a negative over a negative and a negative, which makes that negative. We want a greater than, so all of these would be open circles. And we want to know when it's positive, so it's positive in between negative 6 and 1, and then 2 to infinity. So the final answer here would be negative 6 to 1, union 2 to infinity. I hope you found this video helpful on solving rational inequalities.